Hey guys, the objective for this video is to revise the Buckingham pi theorem. So the Buckingham pi theorem, hopefully you did this last year. In this course, we're just going to touch on the Buckingham pi theorem. It's not going to be so important. What's going to be more important is the dimensionless pi groups you're going to use to compare experiments of different scale. And that's one of the main uses of the Buckingham pi theorem. It allows us to produce what's called dimensionless pi groups. And each of those can be used to essentially come up with relationships between two similar experiments without having to consider reducing all of those variables. We can just consider the relationship between a group of variables that remain common, and those are a dimensionless pi group. Now, in this course, we'll have a number of known dimensionless pi groups, but using the Buckingham pi theorem, we were able to produce our own dimensionless pi groups, and sometimes we got pi groups that we already knew, like, for example, Reynolds number or Froude's number are dimensionless pi groups that you can produce. So essentially, you're taking a variable which is a function of a lot of other variables, and you're replacing that as a function of a couple of dimensionless pi groups, and that's really dependent on the number of different variables that we have and the number of reference dimensions we have, and that's in terms of the MLT system. So I'll quickly just do a little bit of revision on all of that now. So the process is essentially